This presentation describes the Cloud Computing Reference Architecture models as defined by the National Institute of Standards and Technology. You should have already read the documents provided in the Week 1 content area before viewing this presentation. In addition, you should have already viewed the Introduction to Cloud Computing, the Cloud Computer Service Models, and the Cloud Computer Deployment Models presentations, which are also available in the Week 1 content area. The topics for this presentation include the NIST Cloud Computing Reference Architecture, including the major actors and components defined in the Cloud Computing Reference Architecture document. There are several cloud providers who have modified the reference architecture to further refine their specific offerings. This presentation will provide links to these vendor-specific reference architecture documents. A summary and list of references are included near the end of this presentation. The National Institute of Standards and Technology provided a cloud computing reference architecture in 2011. This document provides a high-level description of cloud capabilities, functions, actors, and a conceptual model for a guide for vendors who become cloud providers. Each cloud provider will use this reference architecture to develop their own reference document with specific and possibly unique features. Through the Cloud Computing Reference Architecture, common functionality and operations can be defined and refined through time. The NIST Conceptual Reference Model includes 5 actors, each with specific levels of functionality and layers. The actors include the cloud provider, cloud consumer, cloud auditor, cloud broker, and cloud carrier. Each of these actors will be defined in more detail during this presentation. Notice, the security and privacy support all aspects of the functionality in the cloud provider. However, in most cases, security is a shared model between the provider and consumer. For example, if a consumer installs a database on a platform from a cloud provider, the cloud provider will maintain the platform, but the consumer will maintain the database. A cloud consumer uses the services and resources provided by cloud provider, whereas the cloud provider makes those services and resources available to the consumer. A cloud carrier provides connectivity and connectivity needed to support the cloud provider services. For example, Verizon of AT&T may provide the foundational connectivity between cloud centers as needed. A cloud auditor is a party that can perform an independent examination of cloud service security controls. Audits are performed to verify conformance to standards through review of objective evidence. Security controls include the management, operational, and technical safeguards employed within an organizational information system to protect the confidentiality, integrity, and availability of the system and its information. Security controls are described in detail in the NIST Special Publication 800-53. Cloud brokers are often third parties who optimize the cloud resources and negotiate contracts and interactions between providers and consumers. Some additional definitions associated with cloud computing are needed to understand the service and possible issues with cloud computing and computing in general.
Each service provided by major cloud providers will have an SLA associated with it. For example, compute, databases, simple message services and simple storage service and other services will have unique service level agreements associated with them.
The examples URLs from Amazon Web Services and Google, provided on this slide, should be reviewed and compared for similarities and differences. PII stands for Personal Identifiable Information. For privacy, PII is critical to understand and the sensitive data must be protected. For example, not exposing social security numbers, driver's license, data of birth will help deter identity theft. As shown in the CCRA conceptual model, several components are included in the cloud computing reference architecture. The public, private, and hybrid deployment models have previously been discussed. Service orchestration allows cloud providers to better manage and coordinate the resources provided to cloud consumers. In addition, a suite of cloud service management tools are usually available for assisting in logging file, managing users, managing files, and other activities to keep service efficient and secure. Security and privacy are a joint, shared responsibility between the cloud provider and the cloud consumer. The provider makes sure the facilities are secure, but the consumer must store data appropriately and exercise best practices, such as defense in depth, and making sure users have only the permissions and privileges necessary to complete their jobs. The service orchestration components includes the service, resource abstraction and control, and physical resource layers. The service layers have been previously discussed and include software as a service, platform as a service and infrastructure as a service layers. The virtual machines, storage and other computer resources are managed within the resource abstraction and control layer. Finally, the physical resource layer includes both the computer requirement and environmental controls such as heating and air condition, and power needed to run and store all of the physical computing resources. Often, cloud providers will establish multiple zones for redundancy and security. The physical location of the cloud centers also has some impact on round-trip communications. A center closer to the customer will usually result in shorter transit times for electronic communications. Security, which is a focus for this course, and for most information technology and cloud providers, is diverse and comprehensive, including physical, software, hardware and network security. Everyone using the cloud and those providing cloud services must be actively involved in securing the environment. Security plans should be created that clearly define how a consumer will protect data privacy and use security best practices in all applications and models deployed. The NIST Special Publication 800-53 is an excellent resource to help cloud consumers and cloud providers work to protect confidentiality, integrity and availability. Security controls and risk management must be in place and updated frequently to combat the latest threats and vulnerabilities. Organizations striving for security excellence will have responsive and well-trained teams knowledgeable of the latest tools and threats. The cloud services management component includes business support, provisioning and configuration, and portability and interoperability aspects. Business-related services help ensure cloud providers have a set of useful services fulfilling clients' requirements and needs. Part of this business model will include the ability to rapidly provision cloud services and monitor services to alert users of issues. For example, alerts can be triggered when storage space exceeds a certain value, or the number of hits for a website reaches a business goal. The portability requirement may be one of the least supported by cloud providers. Cloud providers will compete for a company's business and most don't like to share customers and clients with their competitors. This is an area where third-party tools and providers may need to assist. Taking a closer look, the cloud services business support reveals specific areas of focus in customer management, contract management, inventory management, accounting and billing, reporting and auditing, and pricing and rating. For example, a cloud provider must provide an easy process or interface for opening and monitoring accounts. A customer should be able to view their service usage at any time and even have a reasonable projection what the invoice will be at the end of the month, assuming they continue using resources at the same level. The portability and interoperability aspect of cloud services management is critical if a consumer wants to share data and applications across multiple cloud providers. However, tools and processes for moving data between cloud providers can result in expensive data transfer costs. Once data resides on a specific cloud provider, removal and transfer to another provider is possible but involves some manual processes and often starting and rebuilding services on the new provider. Cloud providers need to work to improve the portability and interoperability so that consumers will be able to. Oracle, Microsoft and others have published their own cloud computer reference architectures. The links on this slide provide the current locations of these documents. This slide lists references used in the presentation.